Hello, how are you? Okay, today something different gonna talking about or difference between two population about what? Paired sample. Okay, paired sample. So what's the paired sample? So first of all, so before we talk about independent, right? Now it's dependent only difference. So sample describe estimation, hypothesis, testing. So difference between two population mean dependent, which means same sample. Okay, so here two dependent sample and two data value. Okay, each one of each sample. So collect from the same source the element. Hence, we call pair matching a matched sample. So, which means whatever they mention there, conclusion is the same source. Okay, same source. Okay, same source here. So two sample pair match sample. So each data values collected from the one sample there's corresponding value second sample. Okay, anyway the corresponding something relative, which means conclusion is same sample. Okay, actually same source. Okay, same condition. Okay, so pair difference between two data value, each element same sample, two sample denote D. So come from same place. Okay, so sample size we know the n and degree of freedom n minus 1, right? And let's say we're going to define using D. D means what? A paired difference. Okay, two sample difference between two sample. Okay, this one called D. So mu D, the mean paired difference to pairs difference population. Sigma same thing, standard deviation paired difference population, and D bar the mean of sample. So before like X bar, right? Now is paired difference. This is using D. So we're not gonna using X anymore, S anymore here. So SD sample standard deviation. Okay, and n is number of pair difference value. Okay, looks like all same before using X bar. Right now just D, this difference. All right, so we have two sample, so we are looking for mean and standard deviation for paired difference, two sample. Okay, the value of mean sample, so like D bar means the mean, yeah, means mean. Okay, SD is standard deviation for sample. Okay, so this is calculation, the formula to remember, like X bar before like X over N, right? Kind of same idea. This one too, like X sigma X square, right? And subtract sigma X square over N, right? N minus 1. When using N minus 1 sample, right? If N is population or different. But anyway, same idea. So here we pair the sample instead of X. We don't use here. Instead using mu1, mu2. Okay, so sample statistic using D. Reference D. U. D. U. Sorry, mu D. Okay. So one more time. We're gonna using D. So this one mu D. Okay. So D mu is the mean, right? And D is the difference. And the bar is the sample. Okay. Okay. So actually, value of D bar always like that. Remember, same thing. So mu D always like that. Okay. Already difference. D means difference. Okay. All right. So sampling distribution mean standard deviation d bar. Okay, so what's the number of pair value larger than 30 with central limit theorem, right? So the time d bar approximately normal the mean standard deviation, which means is this formula. Do you remember central limit theorem? So r and mu same, right? And standard deviation 4 divided by sample size, square root sample size. Okay. Okay. So like previous same thing, we're gonna discuss we're gonna find out. Okay, before right, estimate standard deviation. First, standard deviation. There are three conditions. First of all, n should be less than 30, and sigma unknown, and population pair of difference should be normal. Okay, three condition. Then we say t distribution. Do you know why this less than 30? Right, less than 30. Always using t, right? And the sigma unknown, which means the sample, right? So this will be normal distribution. Okay. So t distribution using make inference u mu d standard deviation here sd, because we don't know sigma. So using formula like that, sd divided square root n, right? So like sd, sorry, d. It's hard to see inside, right? Alright, so we have two things think about. First of all, interval estimate. Second, hypothesis test, right? First of all, interval estimate. So mean at d bar pair of this difference. So point estimate du, but before x bar as point estimate mu, right? Same idea. So confidence interval du approximately normal, okay, and confidence interval of du, sorry, mu d, sorry, 1 minus alpha 100% confidence interval mu d. So we have formula before. Do you remember x bar plus minus t like s or x bar, right? Same idea. We're using d bar. So the t or t distribution table, right? And confidence degree freedom n minus 1. So we need, when you're using t distribution, we need a significant level and degree freedom, right? Right, apply the new problem. This problem number. So confidence interval mu d per sample. Okay. Okay, researcher wanted to find the effort special diet. Okay, so how many people will get here? Sample 7 people, sample size, and we're gonna checking the before after. Okay. So like we have 7 people, 1, 2, 7 adult, and we're gonna check them before after, right? Pair the sample because non-independent, before after because same guy, right? Same person, same adult. That's why dependent. So question is du, I'm sorry, mu d mean, right? And they given significant level, confidence interval 95%, right? So assume that this pair difference, but normal. We always normal. So because information obtained the paired sample, so you make confidence interval paired difference mean, which means du mu d. Oh, I'm sorry about that. The mean, right? Mean is mu d. So sample using paired difference between difference here of that. So mean is d bar. Okay. So this one there, and sample size 7. Okay, so D is difference. What? Okay, systolic blood pressure, adult what? Before after. Okay, so we know the before after. Okay, so we're gonna difference is after, subtract before. Okay, so from here to, from before to after. Oh, change it. Oh, sorry, maybe change it here. Should be okay. This one before, this one after. Okay, after. Okay, because we're gonna do this way before. We have to subtract here. So before to after. Okay, we're gonna compare. Okay, so we have data. How about here? Like here, before, after. This difference. Okay, understand that? So before, after, before, after. Okay, so the difference, we have a summation for that, the mean, right? One more time to remember x bar, x and n, right? Same idea. And sigma, using same idea, using this one. So we try to make a table first, like chapter 3 we talked about before, right? So summation for that and the summation for that, but this is square because we just plug in number from the table. Okay, now standard deviation formula. I need to mess up, I need to clean up here. Okay, okay, that's better. Okay, so using this formula, right? So standard deviation 4.0766461. Okay, those 95 confidence interval. So first of all, area alpha significant level over 2. So 5.5 because half of them, right? 95%, about 0.25. So degree of freedom n minus 1 will be 6, and we're gonna try to find the t value, degree of freedom, and area. In the table you can use find 2.447 from the table. Okay, so therefore conclusion, 95 confidence interval 4 is this formula, right? Like d bar plus minus t s d bar. You know, d means the mean of a sample, but difference, like one sample, paired sample, right? So d is paired sample mean. Okay, d s d bar is standard deviation for paired sample anyway. So anyway, this number from 5 and this one for t value, and here standard deviation value, here let's plug in and come out minus 4.98, 1498. So our conclusion is 95 confidence interval mean difference between systolic blood pressure before after. So dietary plan, so all adult patient between this number. Okay, this number. So 95% people come out between this number. Okay, all right, next one will be what? Hypothesis testing. Okay, we should do that. Interval confidence interval, and hypothesis testing. So this is du, mu d. Oh, I'm sorry, mu d. Keep using that. So sample here. So if you compute like x bar one more time, so d means pair. Okay, paired. This one just sample. This paired sample. This different. Okay. Okay. So we know that if greater than 30 should be what? Normal distribution, right? If less than 30, we have t distribution, right? So when you t distribution, you should assumption what should be what normal, always normal. Central limit error. So standard deviation we don't know for population. So that's why we're using sample standard deviation. Alright, so value of statistic t d bar, like mean of paired sample using this formula. Okay, t value, and this one formula subtract from hypothesis, right? This one we're gonna do a substitute, sorry, and s bar, the kind of formula. Okay, so this value we saw before is sample, and we are looking for sample paired sample standard deviation calculation, right? Okay, all right. So example problem, left-hand problem. So company wanted to attend a course how to successful salesperson. Anyway, so can you increase average sale employee? So 6 of salesperson. So we sample size 6, and we are checking also before after. Okay, before after. That's why in dependent problem like that. So we check in before after before after. Okay, so 1% significant level, right? So they checking what hypothesis test always, but two tail, one tail, left, both tail, left tail, right tail. So we should do that. In here, the mean weekly sales person increase. So before to after increase. We are looking for increase. Okay. So it's normal too, right? So 1% significant level, sample size 6. Okay. And paired sample, right? Of course, paired sample. And pair difference, this one, mu d, and pair d, the mean, the sample. Okay, so should be course before, yeah, before subtract after. Okay, should be before the after. This is why they check increase or not before the after. Okay, so null hypothesis and alternative hypothesis. So probably not equal, right? Not equal increase. And they said increase. Increase means this one before, right? After. Okay. Increase means after is greater, right? So this was less. Okay. So increase means should be before is and after. This one is increase, right? Okay. That's why I look at this one. We say left tail best test. Oh, okay. Okay, today lots of block here. Okay, anyway, left hand, right? Right. Okay. So distribution use sample size should be 30 less, right? And normal, unknown. And then we're getting t distribution. I think red color is better. Right, let me change it. Okay. Okay. Small, normal, unknown, small. That's why t distribution. Okay. Alright, continue. Step 3. Step 3 is rejection or non-rejection area. We can find out. Okay, left tail. So, significant level 1% and degree of freedom 5, because n minus 1, n is 6 anyway. So, t value degree of freedom 5, area 0.01. So, using the table, we got that negative 3.365. So how it looks like that. Okay, yeah. So this reject area. So calculation for test the statistics, find the t-value. So before we find mean and standard deviation using the table, so before, after. So subtract, comma difference, okay, summation for that, and square the summation. Okay, this formula d sigma, which means here 25, right, and divide the c as 6 sample size, this number, and standard deviation for sample, which means this number from the table. Okay, now difference sample standard deviation this way, this number. Okay, well, you can do the math. So finally we try to find the t value using plugin. D value summate, d value come here, right, and the mu value the 0 because it's equal 0. This value from here, right, standard deviation, this come out, which will this t value. Okay, so step 5, conclusion. So t value here and that value here, we compare this number and this number, this number. So here 3.87, which mean about here, right, negative 3.870, which mean what? Reject. So we got the reject. Conclusion: mean weekly salesman, a salesperson, increase result for the over the discourse. Okay, so increase, so reject. So reject means not same, it's increase, right? P value. So using this value and degree of freedom, we find a close number, which means 4 point, because positive 4.032 degree of freedom. When you calculate p value, about 0.005, like 0.5%. So compare signature value to 1%. So 1% is bigger than this p value, right? So that's why rejected 2. Alright, okay, one more question. This one actually from the example 10-12. Same question, blood check, blood. So after, before 6%, 6 adult, before after. So before after, you can check. But only difference is significant level 5%, before dying 5%, now 5%. And difference, right? Difference in two tail, right? And normal. That's why normal are the two tail test is difference. So 5% significant level, sample size is 7, they given, and this difference from what? Before after. Okay, so simply before, so before after, before this one subtraction. Okay, so null hypothesis, alternative hypothesis. So there's a difference, right? So first one is not difference, alternative hypothesis, null hypothesis. So alternative hypothesis different. Okay, like that's why two-tailed testing. Okay, so what kind of distribution? The small size, right, and normal and unknown, supposed to be t distribution. Okay. Alright, step 4, using this information. So significant level 0.5, 5% divided 2, right? So 2.5%. The degree of freedom n minus 1, 6, and t value from the table about here. Okay, from the table, because two tail both sides, so you can find some number 2.447 plus minus. So how it looks like that. Two-tail test. Okay, calculation part. So d bar x sigma, so mean. So we have table before after and subtract, right? 70 and this number. Sigma summation d and d square. So we are looking for d bar, the mean of difference. So all summation divided 7. And SD, which means this is summation for mean, we are looking for difference because paired sample defines square root n. this number, and using t-value formula plug in there, come out there. 5 come here, this number come here, so suppose if this one is going 0, of course 0. Alright, so make a decision, two messages. First of all, testing statistics, this number from t-value and the t-value compare. So like 1.227 about here. 1.226, okay, 26. So do not reject. So because of non-rejection region, do not reject or fail to reject. So we say not different. Okay, not difference. Before asking different, not difference, just same. Okay, p-value. So from the here and degree of freedom and the close number 1.440. Degree of freedom, p-value will be 0.10 times 2, so 0.2. So signature level 5%, which is 0.5, so should be greater than. So this number is greater, right? That's why I failed to reject. Same idea. Okay, do you understand that? Looks like lots of things I talking about, but exactly same, almost same to 10.2 and 10.3. Only difference is dependent data. Okay, so call not dependent data, a dependent sample. We call parent sample. Okay, calculation almost same. All right, let me give the homework, and you can check it. If you have question, let me know. See you next time. Bye bye.